All right, this is your review for level. All right, so on the first ones, all you're doing is you want to express it in exponential form. So you should have an exponent. So, for instance, on this one, you have to know what your base is. So the base stays the base and the other switch place. So this would be 20 to the power of 14, because remember a log always equals the exponent, and then equals x. Now you're just converting here. Okay, so for instance on this one, this is your base. So the base stays the base and the other switch place. So you got 32 to the power of 1/5 equals 2. Alright, on these down here you're going to express them in log form. So I should see the word log. So you have to know what the base is. So for instance, this is your base here. So log base 5 of 20 equals x minus 8. Alright, on number 8 here, again you have an e. So it's going to be the natural log. So ln of 20 equals x. Okay, on the next one here, you're just determining if there's solutions or not. So really, the easiest thing to sometimes do here is to just substitute them in, or you could just solve them. So if I cross that out, that gives me x squared plus 12x equals negative 9x minus 2. And that gives me x squared plus 9x plus 14 equals 0. I have to make it equal 0 because of the x squared. If I factor that, I get x plus 7, and I also get x minus 2. So x equals negative 7, and x equals 2. And negative 7 is the only answer they gave me. Alright, on this one here, I would suggest that you just type it into the calculator and figure out which one. So here I'd have log, and then I would substitute the x in for the x right there. So I have log 12.5 plus log 8, and that gives me 2. And that's exactly what I want. So this is your answer. Now I'm going to try the other one just in case. So if I do log, and then again I'm going to substitute that 2 in. So log 2 plus log 8, and that does not give me 2. So that can't be the answer. Okay, on these down here, this is where I had y'all highlight the base and the exponent. So here's your base and exponent, base and exponent. And remember, what you want to do is you want to get that base and that exponent by themselves. So for instance, on this one, I'd have to add the 3 over. That gives you 5 to the power of 3x equals 15. Alright, so now that I have this part by itself, I'm going to convert it. So log base 5 of 15 equals 3x, and then divide by 3, and x equals, okay, so this is where I want y'all to use that alpha y equals button. So there's the alpha y equals. And then I'm going to do log base 5 of 15 divided by 3, and you get 0.56. So x is approximately 0.56. Now this one is already by itself, so this one you could literally just kind of type in the answer. So here you have log base 9 of 4 equals x. And again, if you just kind of type that answer in, and you get 9 and then 4, and so x is approximately 0.63. Okay, now 13 is a little different because of that e, so I still want to subtract the 2 over like we always do. But remember that e, you're going to have an ln. So I'm going to do the base stays the base in the other switch place, okay, because this is already by itself, that highlighted part's by itself. So the base is e, so ln of 8 equals x minus 4. And then I want to add the 4 and add the 4. Now, the common mistake here is going to make that 12, but it's not 12. So remember, that's in parentheses, and then you add it. So what's nice is the calculator kind of gives you a clue because it opens up with that parenthesis. So close that parenthesis and then put the plus 4. And you get 6.08. So x is approximately 6.08. Okay, so that should be enough to help you with those. The only thing I would say here is make sure you divide by 4 first on this one. And then now that you have it by itself, now you can convert it to a natural log. All right. Okay, on these here, you're actually starting with a log. So I had told y'all to highlight the log base something. Okay? So once you have that part highlighted, you just want to get it by itself. So for instance, on the first one, I'd multiply by 2 to get rid of the half. And whatever I do on one side, I do to the other. Okay? So that gives me log base 2 of x minus 5 equals 6. So 2 to the power of 6 equals x minus 5, because the base stays the base and the other switch place. Remember, logs always equal the exponents. Okay, so 2 to the power of 6 is 64. So 64 equals x minus 5, and then plus 5, and then x equals 69. All right, on number 18 here, again, I want to try to get that log base 2x by itself, so I'm going to divide by 3. So that gives me log base 2 of x equals 3. And again, there's my base. So the base stays the base and the others switch place, and x equals 8, because 2 times 2 times 2 is 8. Okay, look at 21. Again, I got to get rid of that 2, so I'm going to divide by 2. So I have ln x plus 2 equals, I'll say that's 2.5. Alright, so now I can do the base stays the base and the other switch place. So the base for this is e. So e to the power of 2.5, because again, all logs equal the exponent, equals x plus 2. Then I'm going to subtract 2 and subtract 2. Alright, so I'm going to use the calculator here. So I'm going to have e to the power of 2.5 minus 2, and that gives you about 10.18. So x is approximately 10.18. Okay, on these here, they just want you to identify the base. So on this one here, I see nothing here. So remember, when there's nothing there, it's really a 10. So the base here is 10. The base here is 2. Now it's an exponential, so that's your base, so 7. Now this one, remember, it looks like this, but we never write that. So the base is e here, e. Okay, on this one here, they just want you to evaluate. On this one, you're really just typing it in the calculator. So if I do log 100, that just gives you 2, okay? So this is really just kind of typing it in the calculator. This is all calculator, and then you round to the hundredths. So for instance, if I was to do ln, okay, if I was to do the ln here, so ln of 7, and that gives me 1.95. All right, this one here, you need to write the equation, and we're going to use the growth equation. So a scientist starts with a sample of 50. So it starts off here, so that's your 50. That increases by 60% each hour. So that's your 0.60. Write and solve an equation to determine approximately how long it would take, so I don't know how long, before it reached 900. Okay, so this is the, well, actually, let me rewrite it. I'm going to add the parentheses together. Okay, so this is the part I'd have you highlight. Okay, so you want to divide by 50. And that gives you 18. So 18 equals 1.6 to the power of x. Okay, so because you have your base and your exponent by yourself, you can now convert. So log base 1.6 of 18 equals x. Alright, so I'm going to type that in the calculator. And that gives you 6.15. So as far as the equation goes, it could be 900 equals 50, and then 1.6x. Alright, on the back, so I just want you to find the x-intercept. So for these, y'all, I really just want you to use the calculator. And you have to remember when they're talking about the x-intercept, that's when y equals 0. So I'm going to go to my y equals in the calculator, and let me clear all that out. And I'm going to type in log base 2 of x, and then notice how the minus 2 is on the outside. And I'm going to go to my table, and there's the x-intercept, because that is where it crosses the x-axis. And y is 0. So this is 4, 0. So again, just use the calculator, type it into y equals. So y equals. Alright, this one down here says the solution of log base x of 6 is 2. So again, you have that log base x of 6 by itself. So the base stays the base and the others switch place. And then once you do that, you take the square root of both sides to get that x by itself. And the square root of 6 is 2.44, which is in between 2 and 3. Alright, on 31, again, you're trying to get that base and that exponent by itself, and they are. So I'm going to switch it to log base 8 of 72 equals x. Alright, and if I do that, I get log base 8 of 72, and x is approximately 2.06. So 3 times 2.06 minus 8. Because all I'm doing is, on this one, using your answer from 31, what is the value of this? So that's my answer. So I'm just going to substitute it in there. And I get, when I do that, when I substitute all that in, I get approximately negative 1.82. Okay, on 33, they want you to solve this. So you'll notice you have logs on both sides. This is when you just kind of cancel them out. So that gives you x squared plus 3x minus 36 equals 5x plus 12. And because of the x squared here, I want to make it equal 0. So I'm going to move everything over. Alright, so when I do that, I get x squared minus 2x minus 48 equals 0. I'm going to use 6 and 8 because that gives me 48. And also, if I make that a negative and this a positive, it gives me negative 2. So x equals negative 6 and x equals 8. Now, the quickest way to check this, or one way to check it, is if I actually come over here and do log x squared. So I'm just typing it into y equals. So, hold on one second. Let me get the calculator in a good position. Okay, so I'm going to type in the original problem. And then I'm going to type the other side of it here. And if I go to my table, I'm going to check my two answers. So the two answers I got was negative 6 and 8. So 8's a good answer, because you'll notice that the y1 and the y2 are the same. Those are the same. So 8's good. So x equals 8 is a valid solution. Now I'm going to go check the negative 6. So I can already tell it's going to be a problem because of the error. So here with the negative 6, yeah, they match, but they match with an error message. So that's going to be your extraneous solution. Okay, hopefully that helped, and just let me know if you have any questions. All right.